The only difference between what we did in Section 8 and this section is that now our functions are linear, meaning that they produce a line. A lot of students get very confused by the notation, but if you take a look at these two, notice the only thing that's changed is that f of x has replaced y. Nothing else has changed. And please take note, this f of x is read f of x. We are not multiplying. This is not multiplying. This is saying take a function of x with a given slope, an x variable, and a given y-intercept. Don't forget that our rate of change, or our slope, is given like this. You cannot forget the rate of change formula. Sometimes we see problems written out like this, right? We look for a formula for a linear function f. We are given the slope as 1/3, and then we're told this. Right here, f of x equals 6 is actually a pair of coordinates, and that pair of coordinates is 6, 0. Meaning, if I enter 6 into my function, my answer will be 0. So now I can use point-slope formula if I'd like. We're familiar with point-slope form. Now, the only difference is when I write this as a function, that's it. This is now in function notation. When you are asked for a function, this is the only notation that is correct. This notation would not be considered correct. On this particular type of word problem, what you need to recognize is that you actually have two xy coordinates happening. So what this says is that on some tests, a person scored 140 on a 0 to 175. Create a function rule so that you can convert the score 0 to 100. So what we need to think about is if we have this scale that we're trying to create, if I input, let me erase that. If I input a scale of 0 on my 0 to 175, my output should be 0. If I input 175 on that original scale, my output should be 100. So what we now have is two pairs of coordinates. Our first coordinate is 0, 0, and our second coordinate is 175, 100. If I've got two pairs of coordinates, I know I can find a slope. This gives me 100 over 175, which reduces to 4/7. Now I have a slope. I can put this into point-slope form and determine my y-intercept. Or I could recognize that I already have a y-intercept, because anytime my x-coordinate is 0, that tells me the y-intercept. My y-intercept in this case is also 0. If you need to see it, regardless, I can now write my function